Welcome back, class. It is Tie-Dye Friday, see? Um, and I want to continue where we left off last session. And that is, we were talking about this common feature of our statistics that we've developed so far. So we have, I like to think about it as sort of a toolbox of statistics. And we'll go through this again, right? We started in chapter 5, I think, something like that. We talked about z-scores for individual scores. So how far is a score away from the mean, right? This is a common feature here. But we want to put that in terms of standard deviation, difference over variability. Then we moved into chapters 6 and 7, and we talked about the z-score formula, but now for samples. And so we had, let me move this over a little bit, we had the mean for a sample compared to the mean of the sampling distribution, right? Then divided by the standard error. Again, this is difference over variability. And then we got to a situation where we had to make a guess at sigma and then finally get the standard error. This is a guessed standard error. That is, we made a guess at it. But we still have the sample mean compared to the mean of the sampling distribution, and now compare that to the variability. So this was our t-test, right? Same format for the formula. I just want people to see the similarity. I think it makes it easier when you see that. And then finally, compare one sample to another when we use that pooled variability to get this standard error t-test. Okay, difference over variability. And we talked about the fact that there are two different flavors, is what I like to call them, independent measures t-test and a repeated measures t-test. Now, I'll make a deal with you guys. So this is chapter 9, this is chapter 10. You don't need to read chapter 11. We don't need to go into that repeated measures t-test in that much detail. I just want you to know the difference between an independent measures and a repeated measures, or pre-post, or within subjects. All of those are sort of synonymous. I want you to know the difference in the research design, that is, using the same subjects repeatedly or using two different groups of subjects. What this difference over variability ratio does for us is it allows us to look at different magnitudes, different sizes of the differences, and compare them to the variability. As long as the top is more than twice as big as the bottom, then that gives us some indication that we have a real treatment effect. If the top is not twice as big as the bottom, then we end up failing to reject the null. That's okay. We're at least making our decision based on data. Okay? So that's sort of where we left off. And we're going to skip chapter, so we're going to skip chapter 11, we're going to skip chapter 12, and I'm going to talk just a little bit about chapter 13, but again, I'll make a deal with you. If you pay attention and listen to what I'm talking about, you don't have to read chapter 13. So really, we're looking at chapter 9 and 10, and whatever's in these videos for the final. And then next week we have one more sort of major topic to cover, okay? So, and I'll sort of fill you in on what to expect for the final. So basically T for 2, right? T-test for 2 groups here, or a T-test for a single group. But oftentimes in research, especially in research in psychology, we're really interested in looking at more than 2 groups, right? So the most basic of experiments is when you have a control group and experimental group, and we've used lots of examples with 2 groups, right? But oftentimes we're going to have more than 2 groups, and I just want to show you what to do then, okay? So when you have more than 2 groups, let's do an example, okay? Oftentimes people are interested in the effects of music on people's moods or on their heart rate or on the, whatever it is, people want to look at the effects of music, because music is a very important part in all of our lives, okay? It certainly is in my life, and I'm assuming it is for yours too. So let's look at an example. So here we have the starting of an experiment. So we're going to have a group that's in a quiet condition and a group that's in a music condition. And when I do this in class, I usually ask you guys for what music, you want to listen to. And let's think about how music might influence your ability to, or how it might affect you while you're studying, okay? And so what kind of popular music do you listen to? And I ask people about popular music because I want to, I have a reason for that, okay? So I would ask you, what kind of music, what should we use in our experiment? And I don't know, I'm an old man, so I'm not going to listen to the same things as you guys. And so I don't know. I'm just going to, make something up here. Let's say Dave Matthews. Is that all right? Maybe people know who Dave Matthews is. Okay. So we have some of our folks in a quiet condition, some of them in listening to Dave Matthews music. All right. And let's say we're going to ask them to memorize a list of 20 words while they're listening to music. Okay. And we'll allow them to study that list of 20 words for 10 minutes while they're listening to Dave Matthews in this case. And then we'll ask them to recall those words. Well, the problem with this experiment, and it's a real problem, I want to be able to interpret whatever findings we get. If there's a decrease in the number of words that people remember here, I'm not quite sure we can interpret that and say, well, it's because of the music. Because the essence of music is really that it's a compound stimulus, right? It has melodic components, right? The music. It has a noise component, and it has a lyrical component. And so in order for, if someone wanted to do this research in my research methods class, I would require at least 2 more groups here. So we have a group in a quiet, we have a group in a music condition. But what I would want to include here is another group in white noise, okay? Now, does anybody know what white noise is? That's like static, like, okay, that's sort of like white noise. Now, why do I want to have a white noise group? Well, this group is in quiet. This is the Dave Matthews, right? I mean, if we put the numbers here, let's start with some numbers. This is the number of words that they recall after studying the list for 10 minutes. This is the number of 20 that they recalled. So I'm just making this up. Let's say they remember this many words, okay, in the quiet. And we find in the Dave Matthews that maybe they're remembering this many words, right? I mean, that looks like that might be a difference. Of course, I'm not going to say whether it's a difference or not until I do the statistical analysis. Of course, okay? But it looks like there might be a decrement. The problem is these people are listening to music, the melodic component, but it's also noise. So I don't know if this was because of the music or because it was just not quiet in a noisy condition. So I'm going to look at people in a white noise condition. So they're not in quiet, but it's not Dave Matthews music. And I also want to include another group here, okay? And that is, I want to do Dave Matthews music without lyrics, okay? Because, again, maybe this decrement is due to the fact that they're in a noisy condition. Maybe it's due to the fact that they're listening to the melody, or maybe it's because it's lyrics, okay? And so I would want to include 2 more groups. And let me just put some numbers in here. Okay. So we have 1, 2, 3, 4, 5, 6 people in each of the groups. And just like the way I talked, or what I talked about with the t-test, we could do this experiment as either a between subjects design, independent measures, where we have 6 people here, 6 people here, 6 people here, 6 people here, right? Different people. So that would be 24 people altogether. Or I could do the experiment where I have 6 people and I repeatedly test them in the different conditions. Okay? It's the same research design considerations when we do an experiment like this as when we did it with 2 groups. Okay? In this case, let's assume that we did this as a between subjects design, so that 6 different people here, 6 different people here, 6 different here, 6 different here. Okay? The basic question is what? What is the basic question here? The essential question. I want to know if there's a difference. I want to know if there's a difference between these 4 groups. 4 groups now instead of 2. Okay? So the first step, I'm assuming that you can think about, right? I mean, the first step is to get the means for the quiet group, for the Dave Matthews group, for the white noise group, for the without lyrics group. Okay? So we would get the means there. Now, I'm not interested in getting the means right now. Okay? Let's just wait. And then I'm going to see if there's a difference between these 4 groups. Now, this gets more complicated, okay? And we're not going to do the computations. We're not going to do the computations. We'll do this on a computer when the time comes. When you're in your master's program, your advisor will help you with this. You'll do it on a computer. But I want you to know that we do have a test for multiple groups that is more than 2. If you have 2 groups, guess what? Let's do T for 2. Okay, we're going to do a t-test for 2 groups. If you have more than 2 groups, then we need to think about a different test. I think. I mean, well, let's see what would happen here, right? Let's get our means. Let's get our means for these groups. Can we quick do this? So 19 plus 14 plus 14 equals, divided by 6 equals. So this is 7.83, okay? And for the Dave Matthews group, it's 9 plus 8 plus 11 equals, divided by 6, 4.67. And we have 17 plus 13 plus 17 equals, divided by 6. So, this is 7.83 as well, okay? And then 10 plus 15 plus 4 plus 15 plus 7 equals, divided by 6. Oh, damn it. Let's change this number here, folks. Can we just change that number there, okay? I don't want all these means to come out the same. That just is stupid, okay? 17 plus 17 plus 14 equals. Okay, so this is 8. That's what happens when you just make stuff up on the run here. But our question then is, are there differences between these 4 means? That's the essence of the question, right? And I'm like, well, why can't we just do t-tests? How many pairs can we do here? 1, 2, 3, right? I can compare this to this. I can compare this to this. I can compare this to this. Is that all the comparisons? No. I can do this one, right? I can do this one, and I can do this comparison. So we have 1, 2, 3, 4, 5, 6 what's called pairwise comparisons. Pairwise, P-A-I-R-W-I-S-E, pairwise, right? These are all the possible comparisons of two groups that we can do when we have 4 treatment conditions. I can compare this, this, right? So I can do a t-test here, a t-test here, a t-test here, a t-test here, t-test here, a t-test here. Okay? Now, boy, why do we need a new statistic if I can just do my t-test? You guys could do t-tests, right? And so let's just do our t-test here. Well, the problem with that is every time I do a t-test, if I set my alpha level at 0.05, if I set it for 0.05 here, 0.05 there, right? I mean, that would be step 2, remember? Well, if I keep doing it 6 times, then I have a higher chance of making a type 1 error, because each time it's a 5% chance, but I'm doing it over and over and over again. So I'm increasing the chances that I'm going to make a type 1 error. That is not cool. I want to avoid a type 1 error, okay? Did I say type 1? I want to avoid a type 1 error, so I need to come up with a different test, okay? Also, let's focus on this one here, this t-test, okay? I'm going to compare those two groups. Now remember, when we do a t-test, the comparison of the means goes on the numerator, right? So I'm going to compare 7.83 to 4.67. What goes in the denominator? What goes in the denominator? Sum of squares here, sum of squares here, okay? Those values get put together. We divide by the degrees of freedom, blah, 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 okay? That goes in the denominator. That is a measure of this variability, and this variability goes into the denominator. Everybody with me? This is what I'm talking about here. We compare the two groups. This is a pooled variability measure from the two groups. So if we're doing this t-test, we're going to use the pooled variability from these two, okay? But we really have 4 guesses for sigma. Everybody with me? That's why we're pooling these, because we want to have our best guess for sigma, so let's pool these. But even when we're doing this comparison, listen carefully, even when we're doing this comparison, I'm going to subtract this mean from this mean. I want my best guess for sigma, and I really have 4 guesses here, not just 2. Now, somebody would raise their hand, I hope, and say, well, if we're comparing these means, are these sum of squares, relevant? And my answer is, yes, they are. Let's go back to the conceptual question, right? We're still going to assume one of 2 things. If we fail to reject the null, then all 4 of these groups came from the same population. If we fail to reject, we're saying that all 4 groups came from the same population. If all 4 groups came from the same population, then they should give me a good guess. I'm going to use all 4 as my guess for sigma, okay? Even when I'm just doing this t-test, why not use all 4, right? If we reject the null, this is the tougher one to understand. If we say these groups are different, then why would we use this variability here to help us do this t-test? Well, remember the assumption that a treatment is just going to push the curves around. The treatment's just going to push the curves around if they're different. it's not going to change the variability. So whether we reject the null or fail to reject the null, I can still use these 4 sum of squares to make my best guess for what goes into the denominator. Okay? And that's true, if I'm doing this comparison, I still want to use all 4 in the denominator. If I do this comparison, I want to use all 4 in the denominator, because that gives me my best guess for sigma. That's really what I'm after. Okay? So there's two reasons to do another test. A new statistic, right? Reason number 1, really what I want to do is I want to avoid making a type 1 error. I want to avoid making a type 1 error. If I do 1, 2, 3, 4, 5, 6 different t-tests, and each time I have a 5% chance of making an error, after I get done with 6 tests, what I've done is I've inflated my error. I've inflated the chances I'm going to make a type 1 error. So I want to avoid making a type 1 error. I want to avoid that inflation of making a type 1 error. Okay? Second reason, I want to pool variability from all groups to get my best guess for sigma. Okay? So instead of using just these 2 when I'm making this pairwise comparison, I'm going to make this pairwise comparison, but in the denominator, 1, 2, 3, I'm going to use 4 groups. If I had 5, I would use 5, combine 5 of them. If I had 10 groups, I would combine 10 of them, so on and so forth. That makes my denominator the best guess for sigma, okay? Because I have more information, all right? So I want to avoid making a type 1 error. I also want to pool my variability for all of the groups in the experiment, okay? Now, so here's the deal. We're going to do something called analysis of variance, also known as ANOVA, okay? And this is what a dumbass I was in college. I remember this very well. The professor's talking about analysis of variance, analysis of variance, analysis of variance. Then all of a sudden he started talking about ANOVA. And I'm like, what? I thought we were doing analysis of variance. Listen, analysis of variance. That's, I can't believe I didn't put that together. But the professor didn't explicitly say that to me either. So I'm going to tell that to you, okay? Analysis of variance, or something called ANOVA. We're not going to do the computations, folks. We're not going to do the computations. It would take an entire class to do the computations. And we're sort of running out of time. We got 1 week left. Next week, we're going to make a dramatic shift to another kind of analysis, okay? But analysis of variance is used to look at differences between more than 2 groups. If you have 3 groups, you're going to do analysis of variance. 5 groups, analysis of variance. 10 groups, analysis of variance. Okay? 2 groups, T for 2, T for 2. Okay? More than 2 groups, analysis of variance. Why? Because of this. Okay? We want to pool the variability for all of the groups. Okay, for all of the groups. So we're going to do analysis of variance, and like we had a z-score and a t-score. The analysis of variance is called the F test. We're going to calculate an F from the data set, okay? And I'm just going to show you the conceptual bases of the F ratio, okay? And here it is. We're going to look at variance between groups. I want to know if there's differences between the four groups in this case, okay? Differences. Variance between groups, okay? It looks a little bit different, but that's because I have more than two groups here. It's not just one difference, it's up to 6 differences, okay? Variance still means difference. How varied are the means? I want to know, how do these means differ, okay? Between the groups, this way. This is what's called a matrix. So we have differences this way, okay? That's the between groups. And we have differences this way. That's within groups. I have differences between groups, okay? And I have differences within groups. All the people here were in the quiet condition, but there's still some differences here, right? All the people here were in the Dave Matthews group, but there's still differences in what they remember. White noise without lyrics, okay? So we're going to look at, how do these means differ? That's the top. And then we're going to look at the differences here. So we're going to do this. It's a ratio. The variance between the groups compared to the variance within each group, okay? What I'm asking is, if you're treated in exactly the same way, there's still people that differ. Treated in exactly the same way, people still remember different numbers of words, okay? So any difference that we see here, needs to be compared to the differences that we see within the groups, okay? Any differences we see here need to be compared to the difference we see within here. So all of these sums of squares go in here. All the sums of squares go in here, okay? 4 groups. And it gets, we divide by degrees of freedom and all that stuff. I'm not going to get into it, folks, okay? I don't even think you need to read chapter 13. I don't think it would be efficient. Just please listen to what I'm saying, okay? Listen to it again. You can always replay the video, right? This is the variance that we see within the groups. When people are being treated in the same way, we still see that there's variability, okay? This is the differences, now in this case, differences between the groups. So we still have this basic notion of, difference over variability. Difference between the groups compared to the variability within the groups. Difference between the groups and what we see within the groups, okay? We saw the same thing here. This is between the two groups, right? We got this from putting the sum of squares together. Are you with me? This is the difference between the two groups. This is when we combine the sum of squares. This is the differences between the groups. This is combining all these sums of squares. And it's not just a simple addition. We're going to do the division by degrees of freedom and all that stuff. And we get an F ratio. punch in all the numbers, you get a value for F, and then guess what you do? You look at a critical value for F, you look at a critical value, you compare what you calculated to the critical value, and if what you calculated was larger than the critical, then that means there were differences somewhere in the treatment. Of course, you need to go back then, and if we have an example like this, I mean, I made it pretty obvious just so that we can talk about it, but you certainly need to do your statistical analysis. But it looks like this one and this one and this one are the same, and this one is different, okay? We would have to go through and do the whole analysis. The reason that we have to have 4 groups to make any sense of this experiment, if we saw that this was a difference, people might say, the music disrupts your memory for these words, right? The music disrupts the memory for these words. But I'm like, but not so fast, because here's the music, and it doesn't have any lyrics. And it looks like there's no difference here, right? And somebody might say, well, it must be the noise. And I'm like, yeah, but the noise group is the same as the quiet group is the same as without lyrics. So these data would suggest that it's the lyrics that's disrupting your memory for the word list. Makes sense, right? But we could have a completely different pattern of results. I made these up. It could be that compared to this one, all 3 of these show a decrement. If that were the case, then I would suggest it's the noise. Okay? I'm just trying to get across to you that there are really important reasons in a lot of research to have more than 2 groups. Okay? I would not be able to interpret this without looking at these 4 conditions. In order to look at 4 conditions, you need to be careful. I don't want to just do repeated t-tests. 1, 2, 3, 4, 5, 6 t-tests. You guys could absolutely do that. I mean, you're capable of doing t-tests, but it creates problems. You want to avoid making a type 1 error. If I do 6 t-tests, then I'm going to inflate the probability of making a type 1 error. So I want to avoid making a type 1 error. So I'm going to combine all the, I'm going to do 1 test instead of 6 different t-tests. And then secondly, and I think even if we do this test, I want to use all of my information about variability to give me my best guess for sigma. Okay? So this is like, I want to avoid making a type 1 error. That's kind of something I want to stay away from. That's why I'm developing a new test. But there's something I really want to approach too, and that is I want to pool variability from all of my groups so I can get my best guess for sigma. In a way, I have, 1, 2, 3, 4 different guesses I can combine. I can pool that variability and make the best guess for sigma. The test is called analysis of variance, also called ANOVA. Same thing, analysis of variance. Okay. The structure here is we're going to look at the differences between the groups, and then we're going to compare that to the variability within the groups. Difference between the groups, variability within the groups. Okay. And that gives us our F value. Once we calculate the F value, look at a critical value, this is similar to what we did with Z, similar to what we did with T. The F has a completely different table in the back of the book. It's much more complicated, but it's the same logic. That is, we get a calculated value. If our calculated value is bigger than the critical value, then we reject the null and we say there's a difference between the groups. Okay? I'm going to leave it there. This is a little bit of a short video, right? But it's Tie-Dye Friday, and we're done with all of the statistical stuff where we're looking at difference between groups, difference between a number in the mean, difference between a sample mean and the sampling distribution mean, 2-sample t-test, 1-sample t-test, finally the more complex analysis of variance when you have more than 2 groups, okay? And if you go to graduate school, you'll probably sort of start here. So I'm good with us ending here for our semester in terms of, we still got more to do, okay? But these are all the tests that are used to look at differences. Next week, we will look at correlations, which is a completely different question, and it's very important. And we'll start on Monday looking at a research study and figuring out that it's really a correlation is a different question than looking at differences between groups. Okay, differences between groups are experimental. Next week we'll talk about correlational. Okay, so I'm going to let you go early today, right? If you need to, watch the video over. Make sure you have the conceptual kind of underpinnings for why a new test is needed. It's really of the same structure, difference over variability. Difference between groups, variability within groups, okay? But it's just more complex. So stay safe, everyone, and I'll see you on Monday.